All right, let's now program a Machin-like formula using MATLAB. Now I'm going to do this a little differently than I've done before, and maybe a little more sophisticated way. I'm going to write an M file, but it's going to contain two different functions. The first one is going to do the basic calculation, and it's going to call a second one that actually finds the value for the arctangent. So I need a name first. I'm going to call this edit. Let's just call it Machin. I'm pretty sure there's no command of that name in MATLAB. Do you want to create it? You bet. Let's do that. Okay. Okay, so far so good. As always, clear the screen. Now, first thing I'm going to need to do is let's calculate estimates of pi for number of terms up to 10. And we'll see how this goes. Now, we don't need more than this because these approaches are so efficient that we're going to get good estimates for a very small number of terms. Now, I'm going to do two different Machin formulae, but let's just use the simple one from the board earlier. And I'm going to write 4 times. I'm going to create a function called arctan. There's no arc_tan in MATLAB, so I'm going to write that. And what I'm going to do is I'm going to send it the value of x at which I want it to calculate and how many terms, n. Right, and that's here. This is the number of terms we're going to be stepping through here. So there's that. We need to add that other term. And also n. And the semicolon there because I don't want that echoing to the screen. I'm also going to want to know what the error is rather than have you watch me type it again. I'm just going to paste it in here from a set of notes I've got on the other screen. So there's the error, and it's the same error we used before, pi minus our estimate of pi, all normalized by pi. And that's it. Now I'm going to need to plot this. So let's plot it, and again on a semi-log plot as we had to do before, because the errors get so small we really need semi-log to be able to even see it. So return. Now, the only problem here is I want to call arctangent, but I don't have a function called arctangent. I will in a second. All right, I do now, and down here I'm going to say return just so we know that that's another function. Now, AT, I'm going to calculate a number, AT, and that's going to be the value of the arctangent that I calculate using n terms added together. So I'm going to start by saying AT equals 0, just to make sure I clear everything out. All right, I'm going to go from I equal 1 to n. Now, as I said before, when you look at the series approximation that's in Wikipedia, the series starts at n equals 0. Well, MATLAB does not let me have an array index start at 0. Some languages do, some languages don't. MATLAB is one of those languages where array indices have to start at 1. So rather than complicating this, I'm just going to make a number n, and that's going to equal I minus 1. Now, for those of you who are watching, I've already used n up here, and I'm using it down here to mean something else. But when you, let me slide this down a little bit so we can see more of it. When you go into a function, it creates its own workspace. Every function has its own workspace. So the n that's up here is not the same as the n that's down there, so you don't need to worry. And again, just so you don't have to watch me type this in again, I'm going to copy it from my notes. And I'm done with the loop, and there's return. I'm going to get rid of a little bit of white space here to make this fit on my screen better. So all that's going to happen is AT is the value of the arctangent at x for n terms. I'm going to pass those two in, and that number is going to be returned right there and right there, because that's basically calling that function arctan. So let's see, does that look like that ought to work? Yeah, I think that ought to work. Shall we try it? Ah, right there. I forgot my multiplication sign. Now it runs. Okay, that looks pretty good. I'm down to 10 to the minus, almost 10 to the minus 8th after 10 terms. So that's converging very, very quickly, much more quickly than some of the others we've looked at. Well, we did that improved Machin series where instead of 2 and 3, we used 5 over 2 and 7 over 3. Well, let's try it and see what happens. I'm going to call that PI underscore IMP for improved. And again, rather than have you watch me type it all in, let me just paste it in here. Let me clean up the spacing here. There, got that. Well, let's take a look and see what look on the plot here. I'm going to have to add that. So let's say hold on. So there we go. And let's put a legend on here so we can know what we're looking at. So this is 2 plus I times 3 plus I. And the second one, should I call that improved? And that should run. Let's go ahead and run that and see what we get. Oh boy, look at that. Man, doesn't get any better than that, does it? All right, that's microscopically small. I'm going to right click there and hit font. Take that up to 18. That's a little better. Let's do the same thing. I'm going to right click there and take that up to 14 so we can see it. There, that's much better. And you can see that as good as 2 plus I times 3 plus I is right there, just that little change of going to 5 over 2 and 7 over 3 gets us an extra significant digit almost by the time for every term by the time we get down to 10 terms. Now, an extra significant digit per term is really pretty good. There are better series out there where you can get a couple of significant digits per term. If you go on to the Wikipedia page for estimating pi, you'll find a Machin-like series by Takano from 1982 and by Sturmer probably, from 1896. And these were used to calculate really large numbers of digits of pi, billions or trillions. Here's what they look like. Now this is far beyond anything we need right now. To go to that many digits, you have to go to some fairly sophisticated programming to let you get that many digits on a computer where you may only have 64 bits to describe every number. And that's well beyond the bounds of this course. So with that, let's be done calculating pi and move on to other things. I hope this helps, and we'll talk to you next time.